Welcome to This Explainer. If you're tuning in, you already know artificial intelligence is completely reshaping our world. But today, we aren't just going to passively look at high-level concepts or abstract theories. No way. This is your actionable blueprint. We're stepping right into the shoes of an AI architect. You know, the person who actually bridges the gap between a cutting-edge algorithm and a real-world business problem. You're going to learn exactly how to move from theory to tangible application and understand how, where, and why to deploy these powerful tools to solve actual complex problems on the ground. Okay, let's dive into our roadmap for today. We're going to cover 1. Designing real-world AI solutions. 2. The core AI toolkit. 3. Transforming major industries. 4. Navigating new AI trends. And 5. Building sustainable AI systems. Kicking things off with Section 1, Designing Real-World AI Solutions. So what's the ultimate mission of an AI architect? It's really quite simple. Apply artificial intelligence to design and analyze real-life applications. The absolutely crucial word there is real life. Because, let's be honest, it is one thing for an AI model to work perfectly in a sterile, simulated lab environment, but it's an entirely different beast to deploy it into the messy, unpredictable real world and actually make an impact. Literally every decision you make going forward hinges on that transition from the laboratory to the living, breathing marketplace. Moving right along to Section 2, the Core AI Toolkit. All right, let's pull the first essential instrument out of our AI tool belt, the Expert System. This is an AI application specifically designed to solve complex problems by reasoning through highly specialized bodies of knowledge. Now, unlike some other models, it doesn't necessarily learn on the fly by churning through massive datasets. Instead, it relies heavily on hard-coded if-then rules. Think of a medical diagnostic system, for example. If the patient has a specific fever, and if they have a certain type of cough, then check for a specific respiratory condition. It's really about capturing decades of human expertise in a highly structured, logical format that never gets tired and never makes a careless oversight. Next up is natural language processing, or NLP. This tool bridges a massive, historically frustrating gap in technology. For decades, humans literally had to learn strict code to tell a computer what to do, right? Well, NLP flips the script. It's the branch of AI that helps computers understand, interpret, and manipulate human language. So instead of forcing humans to speak in rigid syntax, NLP forces the computer to meet us where we are. It processes the messy, complex, and highly nuanced ways we naturally communicate with each other. And this brilliantly illustrates the exact mechanics behind NLP. To make that translation magic happen, an architect relies on 3 distinct gears turning behind the scenes. First, grammars establish the structural, foundational rules of the language. Then, parsing acts as the analyzer. It breaks down complex sentences and maps their syntax, which is essentially teaching a machine the crucial difference between let's eat grandma and let's eat grandma. Because, hey, punctuation saves lives. And finally, language models step in to actually predict and generate the text. Together, these 3 components turn raw human babble into actionable machine data. Our third core tool takes AI completely out of the digital realm and drops it straight into the physical one: robotics. This is where computer science, mechanical engineering, and cutting-edge tech all collide. The goal here is physical manifestation. We're talking about producing machines designed to substitute for or directly replicate human actions out in the real world. They have to navigate everything from gravity and friction to totally unexpected physical obstacles. When deploying robotics, an AI architect really has to think in 3 dimensions. You aren't just dealing with code in a cloud server anymore. You've got to consider the actual robots themselves, the highly specialized hardware required to execute precise physical movements with millisecond latency, and, crucially, the exact physical problems they're being deployed to solve, whether that's on a busy factory floor or in a high-stakes hospital operating room. It's this incredibly seamless, highly intricate blend of artificial intelligence and mechanical capability. Which brings us to Section 3, Transforming Major Industries. Just look at the massive scale of these applications across 3 major sectors. In healthcare, AI is rapidly shifting from a cool novelty to an absolute necessity. It's heavily targeted at hyper-accurate patient diagnostics and completely personalized care plans. Over in retail, it's not just about automated checkout lines anymore. It's revolutionizing the entire consumer experience and optimizing impossibly complex global supply chains so your products arrive exactly when you need them. And in banking,
AI is acting as an active digital fortress. It's deployed for advanced financial modeling and fortifies security by detecting fraudulent transactions in mere milliseconds, long before they ever clear.
Next is Section 4, Navigating New AI Trends. Now, what's really interesting about this is how it introduces the modern complications and opportunities in our field, because the modern AI architect must navigate a rapidly changing frontier driven by three massive trends. First up, explainable AI. As our neural networks become these massive black boxes, it is absolutely crucial that we can understand and audit exactly how they reach their decisions. Second is responsible AI, structuring our systems so they operate fairly, safely, and without unintended bias. And third, generative AI, which is a profound shift from simply analyzing existing data to actively creating entirely new original content and solutions.
This brings us to a critical crossroads for any AI architect. You're going to be constantly challenged to weigh the traditional techniques on the left against the recent AI alternatives on the right. It's no longer enough to just know the old reliable ways, right? You have to actively evaluate when a recent breakthrough, like generative or explainable AI, is actually the most effective, efficient choice for the specific problem sitting on your desk. Sometimes, a simple traditional regression model is perfect. Other times, you absolutely need the massive scale of a modern large language model. Knowing the difference is exactly what makes you a great architect.
And finally, Section 5, Building Sustainable AI Systems. Let's move to and see how this all builds into a concrete 5-step architectural workflow. Step 1, you must define a crystal clear problem statement and identify the gap in the current market or research. Step 2, and listen, this sequence is non-negotiable today. Identify the risk and impact your solution will have on society and the environment before you build it. Step 3, only after understanding those parameters do you choose and apply your specific AI tool. Step 4, you design a genuinely sustainable, long-lasting solution. And finally, Step 5, you must effectively present and defend this solution within a team setting. This right here, this is your ultimate blueprint. But hey, an architect's education never truly stops, does it? Beyond this blueprint lies a specific frontier you should absolutely be exploring next: cognitive AI. This represents the absolute pinnacle of current research. It pushes far beyond standard, narrow applications into systems that attempt to genuinely simulate human thought processes, reasoning, and multi-layered problem solving. Make no mistake, it is the next big mountain to climb. We're going to wrap up today with a vital question you must ask yourself every single time you start a new project. When designing your AI solution, how will you identify and mitigate the risks and impacts on society and the environment? Remember, having an incredible toolkit of natural language processing, robotics, and generative AI is really only half the job. True AI architecture requires wielding these powerful tools responsibly and constantly weighing the long-term impact of what you build. Keep that ethical framework front and center as you go out and design the future. Thanks so much for joining me for this explainer.